All right, let's get right into it. Today, we are unpacking a discovery in mathematics that is, and I'm not exaggerating here, absolutely stunning. It's a story about a secret code, a hidden message, that connects two parts of math that seem to have nothing in common. We're talking about chaos theory and the mind-bending geometry of fractals.
And it all kicks off with this number. Just look at it, 4.6692. It kind of seems random, right? But this might be one of the most important numbers you've never heard of. It's a universal constant, just like pi, and it shows up in the strangest places, specifically right at the point where simple, orderly systems completely break down and descend into chaos.
So that's our big mystery for today. Where on earth does this number come from, and what is it doing hiding in other parts of the mathematical universe? We're going to be detectives on this one, following the clues to see how this magic number was first found and where it just reappeared, in a place nobody, and I mean nobody, expected.
So, our first stop on this investigation is to put a name to our number. This isn't just some random string of digits, it's known as the Feigenbaum constant. And in the world of chaos theory, it's a total rock star.
Okay, I know that definition sounds like a real mouthful, but don't worry about the jargon. The main idea is actually pretty simple. This constant is all about a pattern, a process called a period doubling cascade. Just remember that phrase, because it's our first major clue. It's the key to understanding how things fall apart in a surprisingly orderly way.
So what exactly is this path to chaos? Well, our first piece of evidence comes from a field called dynamical systems, which is really just the study of how things change over time. And it turns out a lot of systems don't just snap into chaos randomly. Nope. They follow a very specific, predictable road to get there.
The best way to think about it is to picture a dripping faucet. At first, you've got a steady drip, drip, drip. Super stable. We'll call that period 1. Then you turn the knob just a tiny bit, and it changes to a new rhythm. Drip, drip, pause. Drip, drip, pause. That's period 2. A tiny bit more, and it doubles again to a 4-drip pattern. And this doubling keeps happening faster and faster until, bam, it's just a totally chaotic mess of water. That whole process? That's the period doubling cascade.
And this is where our number, 4.6692 ... makes its grand entrance. It's not just some bystander watching the chaos unfold, it's the universal rulebook for that journey. It predicts the exact ratio for how much you need to turn the tap to get from one doubling to the next. It's literally the speed limit on the road to chaos.
All right, now for our second clue. I want you to completely forget about dripping faucets, because we're jumping into a totally different world. The beautiful, infinitely detailed geometry of fractals. And believe me, this is where the story takes a really fascinating turn.
So, the researchers in this new paper were studying a very specific creature called an Aether fractal. Now, do not worry about that formula on screen. Seriously, all you need to know is that this is the recipe for creating a stunningly complex shape. And deep inside this shape, they found something remarkable. In their own words, the paper describes finding a nested family of closed curves. These curves have a technical name, Stokes lines, but what's important is that they form a special kind of pattern deep within the fractal structure. And this is the perfect way to picture it. Think about those Russian nesting dolls, right? You open one up and there's a smaller, perfect copy inside, and another inside that, and so on. Well, these Stokes lines do the exact same thing. They form a series of beautiful nested curves, each one shrinking inside the last, following this really precise repeating pattern.
Okay, let's pause and recap. Clue number 1, a constant from chaos theory that describes the speed at which systems break down. Clue number 2, a geometric pattern of shrinking nested curves inside a fractal. On the surface, these two ideas are from different planets, but this right here is a moment of the big reveal. Are they connected?
So here's the big question the researchers asked. Can we actually compare these two worlds? Over on the left, in chaos theory, you have the bifurcation points. That's just the moment the faucet's pattern doubles. And on the right, in the fractal, you have the endpoints of those nested curves. Is it possible there's a relationship between the two?
So what did they do? They measured the distance between the endpoints of those nested curves in the fractal. They calculated the ratio of how quickly they were shrinking, and they found that as you go deeper and deeper, that ratio gets closer and closer to a very specific number, 0.2142.
And here we go. This is the punchline. If you take that weird geometric ratio, 0.2142, and you flip it, 1 divided by that number, what do you get? You get 4.6692. You get the Feigenbaum constant. It's the exact same number.
The rule that governs the path to chaos also governs the hidden geometry of this fractal. It's absolutely mind-blowing.
Discovering this connection is one thing, but it just opens up an even bigger question. Why? I mean, why on earth would these two completely separate mathematical concepts be controlled by the exact same universal code? Well, the answer comes from one of the most powerful and profound ideas in all of physics.
It's a tool called the renormalization group, or RG for short. The best way to think of it is like a magical mathematical zoom lens. It lets you look at any system, whether it's a magnet or a stock market, and zoom out. As you zoom, all the messy little surface details fade away, and you're left with just the deep, fundamental pattern, the part of the system that looks the same no matter the scale.
And here is the absolute kicker. The Feigenbaum constant isn't just some random number that this lens finds, it's a property of the zoom lens itself. You could think of it as the magnification setting that reveals this incredible self-similarity in both the path to chaos and the fractal's geometry. It proves this isn't some crazy coincidence, it's a fundamental law of how patterns repeat themselves in our universe.
So what's the big picture here? Let's zoom out one last time and really appreciate what an incredible achievement this is. What this paper has done is build a brand new bridge between entire continents of thought. It's forged a direct, provable link between three massive fields that, until now, were largely separate: the weird geometry of fractals, the study of how systems change over time, and the universal laws of chaos. It's a grand unification of sorts.
So if there's one thing to take away from all this, it's that the world of math is way more interconnected and, honestly, more beautiful than we often give it credit for. Things that seem totally unrelated, like chaos and geometry, are secretly speaking the same language, following the same deep underlying rules.
And that kind of leaves us with a final, really tantalizing question. If a universal code this profound was hiding right here, connecting these two vast ideas, it just makes you wonder, right? What other cosmic secrets, what other universal codes are still out there, hiding in plain sight, just waiting for us to find them?